Hello, computer lovers. From time to time, you need a hex editor. The reason is, for example, this here. I have created one file called test1, and I write into it hello world. And I have created a second file, test2, and I write exactly the same string into it. There's just one byte that has changed. Instead of an O, I write a Ö. And what does it mean? We look at both files. One is 12 bytes big and the other is 13 bytes big. Why that? You can find out with a hex editor. To install a hex editor, I use sudo apt-get install Octeta. So I'm using Linux and the hex editor Octeta. I have already installed it, but I wanted to show you how to do it if you have not. And then you call, for example, Octeta test1, and then you see quite on the left side the addresses of the bytes starting with 0, then the bytes in hexadecimal notation. So 68 is the code is the ASCII code for a lowercase h. 65 is a code for a lowercase e, and so on and so on. And you see that at the end of the file there is a D and then a mysterious 0A. 0A is represented by a dot here because it is a non-writable character. Actually, it is being written, and it is being written as a carriage return, which means you get a line feed. Let's just try to manipulate it here, and let's say 65 instead here. Then this becomes an E, and then I go out of the hex editor and saving it, and I say cat test1, and then you see the E is added, but there is no line feed. While if there is a line feed, I would see it. Let me show it how it works with the line feed. Here I say A. I exit again, saving. And again I say cat test1, and you see after the D there's a line feed, and the prompt continues in a new row. Different it was when I overwrote the 0A with an E, then there was no line feed between the end of the string and the prompt. Okay, so what's going on here? Why do these two files, I say cat test1 and I say cat test2, and in both cases we see that the same amount of characters is being output. So what's going on here? Why is the file test1 13 bytes long and the file test1 is 12 bytes long? Let's find out again with Octeta. We see again here it says hello world, and here we see that instead of the Ö sign there has been put a UniCode character which is read by Linux as an Ö, and the UniCode character is signalized by the first sign being above bit 128, and the second sign then selecting what character it really is. So for expressing the character Ö, Linux needs 2 bytes, and for expressing the character O, Linux needs only 1 byte. If you want to know more about this, have a look at UniCode, especially the UTF-8 code set. Hope you liked it. If yes, please give me a comment, and I'm happy then, and hope to see you soon again.